Hello, boys and girls. This is Mrs. Winkervasio, and today we're going to be covering Chapter 8, Lesson 8.2, Perimeters of Composite Figures. Reference pages to this can be found in your Google Classroom 8.2, pages 326 through 327. All right, let's go ahead and begin with some vocabulary. What are composite figures? A composite figure is made up of triangles, squares, and rectangles, semicircles, and other two-dimensional figures. In other words, if you have any two shapes that are mesh and combined together, they will make a composite figure. So you can have a square and a triangle. That's two shapes meshed together will give you a composite figure. You can have a rectangle and a semicircle, and that could be a composite figure. You just have to have two shapes meshed together, and that's a composite figure. So today, what we're going to do is we're going to be finding the perimeter of each composite figure. So let's go ahead and begin. I have here a composite figure. It looks like it's in the shape of a triangle and a semicircle. So what we're going to do is we're going to look for its perimeter. Remember, the perimeter is the distance around a given shape. So to find the perimeter of a shape, you just add all the sides. In this case, we have a side. This is 8, this is 6. But in this case right here, I'm going to go ahead and highlight it. We do not have a side. We have what is called a semicircle. So let's go ahead and start by listing down all the sides that we have. So as mentioned earlier, we have the side of 8. So we can put 8. And we have the side of 6. Now what we're only missing here is that half circle in yellow. So we're going to go ahead and fill that in after we solve our semicircle. Okay, so in the previous lesson, we learned how to solve for the distance around a circle, which is called the circumference. So to find the circumference of a circle, you have this formula C equals pi d, where pi represents 3.14, so we're going to put 3.14, and d is going to be the diameter. The diameter here for the circle is 10, so we're going to multiply it by 10. So 3.14 times 10 is going to give me 31.4. Now, this C is for a full circle. So because it's for a full circle, that's not going to work for the distance around the yellow part. You need to make sure you cut this in half because we want a semicircle. So this is going to be for the semicircle. You have to cut it in half. And then when you divide the 31.4 by 2, you're going to get the total of 15.7. Now, that 15.7 is going to be the yellow part of the circle. That's the semicircle. So we're going to put 15.7 here. Then now, what I can do is I can take the 3 totals that I have, the half circle, the 8, the 6, and we're going to add it all up. And once you add it all up, you get 29.6 feet for the perimeter. Again, we're just looking for perimeter by adding all the sides. If there's no sides, you have to solve for the outside the circle. You're going to use this formula. Okay? All right, let's go ahead and have you do another composite example. So now this time I have a racetrack. Now you'll see this more in the high schools and the Olympics. So in this racetrack, I noticed that there is a rectangle and 2 semicircles. But if you notice, 2 semicircles will give you a full circle. So we may not have to cut this in half, okay? All right, so first let's take all the numbers that we have. We have that, let's see, the length from here to here, we know says it's 100. So we're going to go ahead and put 100 down. And it seems like we know that from here to here, the radius is 32. But if we want to know the length of the rectangle here, if this is 32, what's the other half going to be? 32. This half is going to also be 32 because it's also a radius. 2 radii gives you a diameter. So what's 32 plus 32? So I have 32 plus 32 is going to give me 64. So the total for this side in purple is 64. And the total for this side is 100. So that takes care of our rectangle. So I'm going to put 100. I'm going to put 64. Now the only thing that we're missing is going to be the half circle here. Now I just noticed we will not be using the 64 because it's not the distance outside around. We only want to know the distance around. So let me go ahead and highlight that. We only want to know this. We only want to know this. And we only want to know the half domes. Okay? So we didn't need the 64. But we do need the 64 because that's going to be the diameter. So now I'm going to go ahead and solve for my diameter or my circumference of one of the circles. So to do that, I'm going to go ahead and solve. I'm going to say C equals pi d. Now, if you're thinking, where's the d diameter? We only have 32 here, but if you look down here, we did 32 plus 32 is d. So we can say that the diameter is 64. So 64 will be used right here. That's the diameter. And then we're going to multiply it by 3.14. So 3.14. Oops, 3.14. That's a 0.14. And so after you multiply that, again, if you don't know how to do it across, you could do it on the side. We're just multiplying. That's going to be 200.96. That's going to be your circumference. Now, that's for a full circle. Normally, we would divide this in half to get our half circle, but, and let me just fix this real quick because some of you guys might wonder what that number is. So let me fix that. That's 3.14 for pi. Okay. But if this 200.96 is for the whole circle, but we only want half and we have another half, we technically don't have to divide this into two because this is a full circle. Two half circles right here gives you a full circle. So we can keep this answer for C. So now we have the outside of this and the outside of this green part. So it's going to be the green part that we just found. So we're going to take 200, add it up with 0.96 and add it to 100. And then you're going to get a total of, you're going to get a total of 300.96. Now, what I do notice though is I left out one more thing. We do have two sides of this purple line. I've only added one of the 100. We need another 100, so let me just go ahead and include that 100 again because there's two of the 100s right there. So I'm going to go ahead and add it up. The final total is going to be 400 and 0.96. So that would be my final answer for the perimeter. You add the 100 here, 100 here. Our green circles are going to be 200.96. Okay? Now again, this could be difficult if you don't see the pieces. So if you're still having trouble understanding this, go ahead and pause the video, stop it, and watch it back so that way you can see the examples again. All right, I would like for you to go ahead and try on your own example number 1. It says 3, but I'm going to go ahead and change this example number 1. And I would like you to try example number 2. If there's questions on this that you don't understand, please jot them down and I will answer them tomorrow. Again, you're cutting the shapes in half if you need to right here. And all you're doing is finding the perimeter, the distance around the shape. Okay? Then afterwards, if you can go ahead and try the exit ticket. Again, you're just finding the perimeter around. If it's difficult, I still want you to try the best you can. And if you have questions, ask me tomorrow. Okay, then. In addition to your on your own, I would like you to do some more practice on problems 9, 10, 11, 12. Again, if it is difficult, I understand it could be difficult, please jot down the questions and we will answer them tomorrow. But please at least try, okay? Have a great day and I'll see you tomorrow. Bye.